Okay, let's solve the question, the next greater element. What this question says, we are given an integer array and for each element return the first element greater than the current element on the right side. If it doesn't exist, mark it as -1. It's very simple. Let's understand this with the example. Okay, let's consider an array. Let's say 2, 7, 3, 4, 2, 1, 9, let's say 3, and for each element we need to find the next greater element. For 2, what it will be? The first element on the right side, which is greater than 2. Which one is it? Let's go to 7. Yeah, 7 is greater than 2. This will be the next greater element for 2. And for 7, 3 is less than 7, so it is not the answer. 4 is less than 7, this is also not the answer. 2 is less than 7, no, this is also not the answer. 1 is also not possible, nothing is possible here. And 9 is greater than 7, right? So 9 is the answer for this. For 3, the next element is 4. 4 is greater than 3, yeah, that is the answer. For 4, again 2 is lesser, 1 is also lesser, and 9 is greater. Yes, 9 is the answer. 2, again 9, 1 is lesser, so 9 is the answer here. For 1, 9 is the answer, and for 9, 3 is lesser, and after that no element exists, so there doesn't exist anything. At that time we need to mark it as -1. And for 3, again there doesn't exist anything, so we mark it as -1. This will be our answer. This is what we need to return at the end. How do we solve this? So first let's how do we solve this using brute force approach? This is very simple, because let me write down again. What we do is just basically go through each element, traverse through each from this to this, and take another variable, let's say j. This will go from I plus 1 to n, and for each array of j we compare it with the this one original one, that is array of I. If array of j is greater than array of I, that means we found the next greater element, right? After that what we need to do, we just need to break from the loop, because we don't need to traverse this side again, because we already found out the next greater element. This we do for each index. We go here 7 and we traverse from here to here and find the next greater element. 3 is not, 4 is not, 2 is not, 1 is not, and when j reaches here, this will execute. It is true, and we assign it to we assign the next greater element of 7 as 9, and we break from the loop and we go to 3 and we do again this one. So what is the time complexity here? This outer for loop will run n times and inner will also run n times in worst case, so it is O of n square. What is space for this ng array? If you consider that, it will be O of n. Yeah. So next, how do we solve this optimally? To do this, we need to understand the concept of monotonic stacks. Okay, what is monotonic stack? It is same as the normal stack, but it will have some order. What kind of order it is? It can be either increasing or it can be decreasing. That is, inside the stack, from, imagine you have the stack here, this is bottom, and we have some top element here, and from top to bottom items will be arranged in either increasing order or decreasing order. This, in normal stack we won't do this operation, but all the other operations like top, off, pop, push, everything will remain same as the normal stack. It is just we add some variation to maintain either increasing or decreasing. How does this help in solving this problem? Let's understand. Take this example, 2, 9, 7, 3, 4, 8, 5, 6. Yeah. Okay. For this we need to find the next greater element. Okay. What we need to do here? We need to traverse from either here or we need to traverse from end. Which one is better here? See, imagine you are at this index 0, 1, 2, 3 and 4, I equals to 4, let's say, and we need, if we traverse from this direction, that is end to here, we have already computed for these three, right? We can use this answer for this. So imagine we are using a stack and storing, let's say, the next greater element. Greater elements are stored in this stack. If we start from this index and when we reach here, we don't have these inside the stack, right? So there is no point in going from first to last. So we here go from last to first, that is I equals to n minus 1 to down to 0. We traverse in this direction. Let's explain this clearly with the demonstration. Seven, 3, 4, 8, 5 and 6. Let's say we have the stack, that is STK, which is initially empty. So basically here stack is nothing but it will indicate the next greater element. Let's see how this works. So we are at here, right? We are starting from end, that is n minus 1, and we see the stack top. What is this in stack top? Nothing. Nothing means in stack, or empty stack means next greater element doesn't exist for this element. For 6 you see the stack, nothing is there, so we mark it as -1, and when we go to 5, sorry, before that what we do, we push 6 to the stack, then we go to 5. For 5 again we will see the stack top, this is top now, 6 is there, 6 is greater than 5, right? So that is the next greater element of 5. Then we push 5, then we go to 8. So now here you see, is 5 greater than 8? No, right? So what we do is, this is not a valid answer, so we pop this. Then we see again stack top, which is the stack top, that is 6. 6 is also lesser than 8, so this is also not the answer. This is also, we pop it. Now there is nothing to pop. As I said before, now stack has become empty and nothing is there in the stack. Nothing is there means NG doesn't exist for this element, so we mark this as -1 and we push 8 to the stack. Then we go to 4. 4 we see the stack top. What is there at stack top? That is 8. 8 is greater than 4, right? So the next greater element is 8 here. Now we mark it as, now we push 4 to the stack. Now we go to 3. Then we see again stack top, that is 4. 4 is greater than 3, right? So we mark 3 as the next greater element, push 3 to the stack top, and then we move to 7. 7. Now for 7, again we will see the stack top. Is 7 is greater than 3, right? So this will become false because 3 is not the next greater element. We pop it. Then we again see the stack top until we find the next greater element. We pop 4 also because this is also not the answer. Then we see 8. Yeah, 8 is the answer. 8 is greater than 7, right? So we mark it as 8. Then we move to 9. Now for 9 again, first we push 7 and then we move to 9. Then again we see stack top. 7 is lesser than 9, so this is also not the answer. We pop this. Then we see the stack of 8. 8 is also lesser than 9, so this is also not the answer, so we pop it. Then we see again stack has become empty, so next greater element doesn't exist, so we mark this as -1. Then we move to 2. Okay, we pushed 9 also. Now we see the stack of 9 is greater than 2, so 9 is the answer here. Yeah, how does this work here? Let me explain with the example. Okay, what was the example? 2, 9, 5, 4, 3, let's say 7 and 2. Okay, how does this stack approach work here? Let's understand clearly with this example. Let's imagine all this as some height of some poles. Okay, this is of size 2, let's say this one, and we stand here and look this side. You can only see greater than this. But you can't see shorter poles. So there is nothing this side, so we mark, obviously it is -1. Now we go to 7. Let's say this as 7. Okay, this height is 7. Then we look this side. Is 2 visible if I see from here? Definitely not, because as I told, shorter one you can't see. When you see towards the right side, and you can only see the bigger one, so 2 is not the answer, so we pop it. Imagine you have any other pole. Let's say, what are the elements lesser than 7? 6, 5, 4, 3, 2 and 1. Imagine you have any other pole here. 6, let's say 6, 5, 4, 3, 2, 1. For all of these elements, 5, 4, 3, 2 and 1, 2 can never be the answer. That's why we are popping from the stack, because 2 is not valid. It doesn't contribute to any answer for after 7 to the left side of 7, because see, for 6 I find the next greater element, it can be 7. For 5 also it can be 7. For 3 also it can be 7. For 2 also it can be 7. But it can never be 2, because there exists some greater elements on the left side of 2, right? So 2 is never the next greater element. That's why we pop it. Okay, let's draw. Wait, this is 2. This was 7. For 7, 2 we eliminated, and the next greater element is, it doesn't exist, right? For this also -1, this also -1. Now we go to 3. Let's say this side as 3. We see this side. We can only see 7. 2 is hidden by 7 because 7 is larger. So this one answer is 7. Now we go to 4. Now from 4 you can't see 3, right? So we eliminate 3 also. We can only see 7 here. For this, answer will be 7. Now next go to 5. I'll write here. Let me draw it down. This was 2, this was 7. This is eliminated, and next one was 3. You can only see 7. Next one was 4. Now if you see this side, you can't see 3, so we eliminate 7, and the next one was 5. Let's say this as height 5. Can you see 4? No, you can't see 4, so we can eliminate this also. Now see, you can only see 7. For this also, answer will be 7. Next is 9. What happens when 9 is there? You can't see anything, so next greater element doesn't exist. These all elements are smaller than 9, so there doesn't exist any next greater element. This will be -1. What is next one now? 2. When I see this side, what is the next greater element? That is 9 here. Only I can see 9. That is the next greater element. 2, it will be 9. I hope you understood this, why we are maintaining a increasing or decreasing order. That is what we call it as monotonic stack. See, we are maintaining a which order? Decreasing order, right? First let's understand why we started from n-1 to 0. Why we started from last? Imagine we are at here, somewhere here, and we processed all these, right? After coming from here, we can see the stack top because we already processed this. This is processed before, and we can see the stack top and get next greater element. But if we start from this side and we don't have anything in stack, right? This side, next greater element, it exists on right side of the array, so we don't have anything in stack to check. So this doesn't make sense to start from 0 to n-1 because we haven't processed the right side element. That will definitely lead to O of n square every time if we start from 0 to n-1. That's why we do from n-1 to 0. So let's write the code and understand this clearly. How to code this monotonic stack. First, what we'll do is we'll take the stack as we discussed in our dry run. Let's take stack which will be empty at first, and we take another array, next greater element. This is also empty. This will be of size n, let's say. So what we do? We need to calculate for every element. That is, we start from last n-1, I equals to n-1 down to 0. We need to calculate, right? Now what we do? We check the stack until we find the next greater element. Until we find next greater element, or stack becomes empty. Either one of these condition. So what it will be? While stack is not empty and stack dot top, we are getting all the lesser elements which are not valid. We need to remove this, right? Stack dot top is less than or equals to our current element. These are not valid next greater elements. These are all lesser elements. So we need to remove this from the stack, right? So we pop it. Once we have done this, we are left out with either empty stack or non-empty stack. If it is empty stack means we didn't find any NG, so we mark it as -1 because there doesn't exist any NG for current array of I. So if stack is not empty means stack dot top exists. That will be the next greater element. So let me write the condition. If not of stack dot empty, that means NG of I will be stack dot top. Else what it will be? NG of I is -1. After all this, what we need to do? We need to push the current element to the stack. Array of, see how it is maintaining order here. Here we are popping all the elements if stack top is lesser than or equals to array of I, right? Imagine you have 7 at stack top, then we have let's say 3, 2, and next we have 15, and our current element was let's say 20. We see 7 is lesser, we pop it, this will execute, and then 3 will pop, 2 will pop. Now this order has become 20 and 15. If you had pushed all these elements, let's say 20, then it will become 7, then it will become 3, then it will become 2, then it will become, let's say, 15, right? See, here we are not maintaining order if we push all the elements. So we remove this 7, 3, 2 and make in a decreasing order 7 and 15. This will maintain this order. I hope you understood the difference between normal, stack and monotonic. Now let's understand the time complexity, time and space complexity here. What is the time and space complexity? Let me erase all this. Let's say time. This will run n times, right? This is very straightforward. Then we will move to this one, this loop. Does this while loop also run n times? The answer is no, because let me explain you why. See, we are popping the element, right? In entire operation, that is n times, from I equals to n minus 1 to down to 0. How many maximum elements that you can pop? How many maximum elements you can pop? You can only pop n elements, right? Not more than that. You can't pop more than n elements, because see here, we are pushing only array elements. Maximum will push n elements, right? You can't pop more than elements, more than n elements. So this pop, push, everything will execute only maximum n times. That will make our time complexity as O of n plus n. In the worst case, that will be O of 2n here. I hope you understood why this is not O of n square. This will be O of 2n in worst case. And what about space complexity? For stack, it is again O of n. If you consider for ng also, ng array also, it will be O of n. This is also O of 2n. Yeah, this is about the next greater elements. Now let's understand, let's take another question which is slight variation of this, that is next smaller element. In previous question we have found the next greater element, right? Now we need to find the next smaller element, that is first element on the right side, which is smaller than current element, else mark it as minus 1. A very straightforward question. So what changes we need to do here? The brute force will also remain same here almost. We just need to change the signs here, because previously we were finding next greater. Now we need to find next smaller, that is first element lesser. Let's take example and understand this. We have, let's say 7, 4, 3, 9, 8, 6, 3, 2, 7. Let's this next smaller element, right? Again, as I said before, I won't explain much again, because we need to start from last only here. What will be the answer for 7? That doesn't exist anything. Answer is minus 1. What is the next smaller element for 2? That doesn't exist. Answer is minus 1. For 3, 2 exists. 2 is lesser than 3. Answer is 2. For 6, 3 will be the answer. For 8, again 6 will be the answer. For 9, 8 will be the answer. For 3, 9 is greater, 8 is greater, 6 is greater, 3 is greater, and 2 is lesser than 3. So for this, answer will be 2. For 4, again 3 is lesser, so 3 will be the answer. For 7, 4 will be the answer. This is what we do. What we do here, let's take the stack and again trace the program. We keep it as empty first. First we are at 7. Let me write this again. 7 4 3 9 8 6. 7 4 3 9 8 6. 3 2 7. 3 2 7. So we are at n minus 1. We see the stack top, nothing is there, minus 1. Now we go to 2. Previously we are checking until we are finding smaller elements. We know that doesn't contribute to answer, and we were popping, that is while not empty and stack dot top is less than or equals to array of I, we were popping, right? This was the condition, that is we are finding smaller elements which are not greater, so we were popping here. So in this case what we need to do, we are finding the next smaller elements, right? So if we are finding greater than or equals to current element, that is larger values, these are larger than current value. Let's say we are at 6 and we go this side, we find example, let's say we had another value 100 here. 100 was at stack dot top, which is greater than 6, right? This is not a valid next smaller element, so we should pop this element. So this condition should become greater than or equals to here. Let's trace this. So 7, nothing existed, so I pushed 7, then I moved to 2. So I see stack top, 7 is there, 7 is greater than 2, right? So this is not the next smaller element, valid one, so we pop it. This condition will execute, and this condition is true, and this will execute. So next we go to we push 2, and next we go to 3, and you see stack top 2 is there, 2 is lesser than 3, right? This is the valid one, so we mark the answer as 2 and we push 3. Then next go to 6, we see stack top 3 is there, yeah, this is the valid one, we push 6, mark 3. Then we go to 8, we see stack top 6 is less than 8, we mark answer as 6, push 8, move to 9, again 8 is there, we push 9, answer is 8. For 3, again now see 9 is greater than 3, pop it, 8 is greater than 3, pop it, 6 is greater than 3, 3 is greater than or equals to 3. This is not a strictly lesser than 3, so 3 is also not the valid answer. Now we see 2 is less than 3, this is the valid answer. We push 3, mark 2, move here. Now we see stack top 3 is lesser than 4, we push 4, mark answer as 3. Now we move to 7, again we see stack top, that is 4 is lesser than 7. This is the correct answer, so we mark it as 4. I don't think so there is explanation here for this. This is just we need to change the lesser than or equals to greater than or equals to here, that is we remove all the elements greater which doesn't contribute to answer here. That is for next smaller element. I hope you understood this approach, and time is again O of 2n and space is O of 2n again. That will be the time and space complexity for these two solutions. I hope you understood the solution. If you understood the solution, please hit the subscribe button and like the solution. Thank you so much.